Hi, welcome to Code.io. This is day 10 of 100 days of code, and this is today's question. So it's called exponentially odd, and let me just read the question first and we'll move on to the approach. So given an array of n positive integers where all numbers all numbers occur even number of times except one number which occurs odd number of times, find the exceptional number. Okay, so I think I read it as exponential odd. I don't remember it properly, but it is exceptionally odd, not exponentially. Okay, fine. So here is the question. You are given an array and the numbers that are present in the array are positive integers. Okay, and these numbers are always present in even number of times, right? So if you have 2, it will be either it will occur 2 times, 4 times or 6 times or any even number of times, right? But there will be one number which has occurred odd number of times and you are supposed to find that number, right? So a brute force approach would be iterating through all the array and counting the number of times each number has occurred, and you can figure out which number has occurred odd number of times, right? So for this you should be using probably a hash map or an array if you actually know the limit of the numbers that are present in this array. But yeah, so it takes space, right? The space complexity would be order of n, where n is the number of distinct characters, right? So it would take space, but we are supposed to write an algorithm that doesn't require space in order to solve this question, because that is what they have been asking in the website site. So okay, so there is one particular behavior or observation that you could do which would really help you to solve this question, and that is XOR. So let me just move this question up and we'll just get into this input. Yeah, okay, so in this particular input we have n equals 7, so the size of the array would be 7 and the array elements are 1, 2, 3, 2, 3, 1 and 3, and as you could see the number 3 has occurred 3 times and every other number has occurred 2 times. So the answer that we should return is 3, right? Because 3 has occurred odd number of times, which is 3 times. So let me come back to the approach, which is XOR, right? So XOR. So if you have learnt about digital circuitry or something like that, you would have heard about this gate called XOR gate, or in general you can tell there is something called XOR operation, right? So you can write a truth table and you will know what an XOR operation is. So let me just write a simple truth table here, and let the variables be a and b, and the answer should be XOR, right? So let that be x. So if you give 0 and 0 as input, the XOR operation will give you 0. Okay, if you give 0 and 1 as input, you will get 1 as output. If you give 1 and 0 as input, you will get 1 as output. If you give 1 and 1 as input, you will get 0 as output. So if you could see, there is a pattern that has occurred here. For the XOR operation to produce 1 as the output, one of the input should be different from the other, right? If both these inputs are same, it will definitely produce 0 as the output. Only when one character is different from the other, or when you get different inputs, the XOR operation will give you 1 as the output, and this is the factor, or this is the observation that you are going to use to solve this question. So how exactly are we going to do this, right? So we know that if you XOR two same numbers, you will get 0 as the output, right? So only when you have odd number of XORs of the same number, you will end up with something which is not 0. Okay, I'm not sure if you completely got it, but let me just tell you once again what I just said, right? So let me just convert this number 3 into binary, right? So the binary value for 3 is 1 1, right? I hope I'm right. Okay, so 1 1 is the binary value for 3, and if you try to XOR and I think the symbol for XOR is that the plus symbol inside a circle. So 1 1 XOR 1 1, right? So I'm representing 3 in binary and I'm trying to take XOR of that. So we know that for the same input you will get 0, right? So this will end up as 0 0. Excuse me. Okay, so you will get 0 0 as the output, right? Now you have XORed 2 3s and you have got 0. Now what if you XOR this output with another 3? Okay, the binary value for 3 is 1 1, and if you try to do the XOR operation once again, you will end up with 1 and 1, because 0 XOR 1 is 1, 0 XOR 1 is 1, and you are getting 3 back again as the output, right? You have got 3 as output. Okay, so this is the observation that I want you to remember. So if you XOR the same number for odd number of times, you will get 0. If you XOR the same number for even number of times, you will get, sorry, let me just rephrase that again. I just confused it a little bit. If you XOR the same number even number of times, you will get 0. If you XOR the same number odd number of times, you will get the number itself, right? Okay, so that is the property that we are going to use, and let me just solve this particular input with that property and you'll understand it better, right? So let me just erase all these things, and we'll first convert these decimal numbers into binary, right? So you have 1. So we'll just represent all these numbers in 2 bits because the maximum value is just 3, and but the binary value for 3 is 1 1, right? Which can be represented in 2 bits. So you are going to represent 1 in binary, which is 0 1, and for 2 it is 1 0, for 3 it is 1 1, for again 2 we have 2, so it is 1 0, we have 3 which is 1 1, you have 1 which is 0 1, and you have 3 again which is 1 1, right? So you are going to take XOR for all these numbers. Okay, you can just do it with 2 numbers at a time. So okay, we'll do that as well. We will just do 2 numbers at a time. So we have 0 1 and 1 0, right? And both these are different. So we are just considering this at this point. So 1 0 it will give you 1, and 0 1 will also give you 1. Okay, so this is the output that we have, and the next number is 1 1, right? So when you take XOR 1 1 with XOR, you will get 0. So 0 0 0 0 is the output now, and we have completed up until this point, and we have 0 0. You are going to take XOR 0 0 with 1 0, and 0 XOR 0 is 0 and 0 XOR 1 is 1, so you are getting 1 0. You are going to take XOR with 1 1 again, and 0 XOR 1 is 1 and 1 XOR 1 is 0. Okay, so we have completed up until this point, and we have 0 1 now. So 0 1 XOR 0 1 will give you 0 0, and finally you have the number 1 1, right? So 0 0 XOR 1 1 gives you 1 1, and the decimal equivalent value for 1 1 is 3. Okay, so this is the answer that you are going to return, and that is the output that we need, right? So this is the property that you are going to use. If you XOR the numbers that are present in this array, the answer would be the required answer, which is the number that has occurred odd number of times, because that is the property of XOR. So hope you got some idea about this logic. Now we'll try to implement this and see if it works. Now I'm here in Geeks for Geeks, and I'll leave the link in the description so you can solve it. The implementation is really simple, very simple. You're just going to create a variable called answer. Okay, and I'm going to initialize it to 0. Now we are just going to traverse through this array, given array, which is ARR, right? So int I equals 0, I less than n, I plus plus. I'm just using a for loop for that, and we are going to take XOR of every number with the answer variable, right? So answer equals answer XOR our current variable, which is ARR of I. Okay, and that is it. You are just going to return this answer variable and you are done with this, right? So it's very simple. You are just taking 0 and using the XOR operation, you are computing all the elements in this array, and you'll end up with the number that is present odd number of times. Now we'll see if this works. So all test cases have been passed, and this logic is working perfectly fine. So you got, I hope you got this logic. If you have any questions, put them in the comments, and if you have solved this, post it on LinkedIn and tag me, and I'll probably see it. And the time complexity for this approach is order of n, because you are traversing this whole array for one time, and the space complexity is just constant because we haven't used any memory which is not constant, right? Okay, so fine. Thank you so much for watching. See you on tomorrow's episode of 100 Days of Code. Bye for now.